Our project is titled as Lip Motion Analysis for Speech Recognition with Deep Learning. We'll be looking into the following topics: the problem statement, objective, abstract, introduction, existing system, proposed system, architecture diagram, software and hardware requirements, modules, conclusion, and future enhancement. Problem statement is that a traditional speech recognition system struggle in noisy environments or when audio data is unavailable. The speech recognition system which we are using right now, when there is a lot of background noise, it becomes difficult for the speech recognition system to analyze what the speaker is trying to convey. And if there's a lot of background audio, it gets harder to convey. So for this, we are going to looking into a visual speech recognition system which can help to interrupt speech by analyzing lip movements, but it faces challenges like speaker variability. Speaker variability is that each and every speaker has his own accent and how they speak and convey information. So in varying speaker as their different accents, so the model needs to be trained on a diverse data set so that we can get an accurate result. So what is the objective? Our objective is to develop a deep learning based system for accurately recognizing speech from lip motion in a silent video sequences. So we'll develop a lip deep learning model which will help to analyze what the speaker is trying to convey from their lip movements. Abstract. So lip reading, as we have know, there have been existing lip readers who try to understand what the speaker is trying to say by analyzing their lip movements. So lip reading has evolved, and from where it began to help deaf people has slowly turned into a service where digital entertainment industry has started utilizing it. We observe that a lot of algorithms reviewed have been exploring various techniques, whether it be a variation from detecting lip features to text generation process itself. But there are some limitations like speaker variability, as we have already addressed, and lightning condition, and various issues are there in the present uh, visual speech recognition model. So introduction: visual speech recognition, also known as lip reading, holds a significant potential for enhancing speech related applications, including dictation in noisy environments, silent dictation in public spaces, hearing aids. So by using deep learning techniques, we'll be developing a visual speech recognition system. So existing system, the problem is that it's trained on a very smaller and less diverse data set that may not include a wide range of accents. When you don't include a wide range of accents and work on a very less data set, the model will be less accurate. The more and more model is trained on a better data set and diverse data set, the accuracy will be more. Struggles with variations in lighting and speaker differences affecting performance. So like when a speaker is speaking and the background condition, the lighting is different, and how the speaker is speaking is different. So we need to develop a model where it will address all these issues, and it combines CNN RN standard way but not may work well together. Word error rate of existing machine learning models is fairly between high and medium. High and medium is the word error rate is number of words which are correctly analyzed and how many are falsely analyzed. So that is the word error rate. So word error rate right now it's very high and medium. The proposed system will be working on a large and diverse data set to enhance generalization across context and speaker. That is, we work on a more diverse data set, they will be more accurate will be our result. So it reduces the word error rate and increases accuracy. And here we'll be working CNN and RN more effectively and allowing them to work together better to capture important details. Designed to be robust against various variations, maintaining performance in real world scenarios. This is the architecture diagram. We'll be inputting an video and there will be pre-processing will be done, and then it will be sent into the deep learning model which will be used to train the data set, and then the output text will be fetched. In pre-processing, we'll be going through various process where the video will be converted from RGB uh, to grayscale so that the videos are processed easily, and then the model will be trained on a various dataset on more and more epochs so that we'll get accurate results. And then finally the text is fetched. Whatever input video we have given will get a subsequent subtitle for that whatever speaker is speaking. So software and hardware requirements is will be working using Python. Deep learning framework is TensorFlow, and the library will be using the OpenCV for analyzing the videos, NumPy and Pandas, and IDE is Visual Studio Code. The first step which we worked on was data collection. So large data sets where people are speaking clearly were required. These videos should ideally show various angle and lighting conditions. So each video is annotated with corresponding transcript to provide supervised learning. So it's a supervised learning, supervised data set basically. So we have collected data set from various sources. One is lip reading in the wild, another is lip reading sentences and grid corpus, and next is data pre-processing. So data pre-processing is crucial for preparing input videos for deep learning model. The process begins with frame extraction, where video frames are sampled at fixed sample rate to maintain temporal consistency. Next is face and lip detection are performed using tools like OpenCV or DLib to locate and crop the mouth region in each frame. The input video pre-processed to facilitate frame by frame analysis. The alignment to the respective videos is also pre-processed. This is the implementation of the second module, that is data pre-processing. Feature extraction focuses on transforming video frames to meaningful representation that captures spatial and temporal information about lip movements. First, facial features are extracted using CNN, which are analyze individual frames to detect lip shapes, position, and texture. These CNNs identify key patterns such as edge and contours to define mouth movements. To capture temporal dynamics of lip movements over time, models like 3D CNNs or sequential frameworks are employed. So this is the implementation. What we have done from a raw data set, that is the video is processed, and that region is only cut. The lip region is only cut, which we need to focus on. So we don't need to process the whole video, that like the whole face of the speaker. We just need to analyze the lip movement. So from RGB video we are converted to grayscale, so it is easier for us to process. And then we can see that there are two different frames. First frame where the mouth is open, and second frame is where the mouth is closed. Then the fourth module is model training. So the model is trained on diverse data sets. So we are using a pre-processed data set from phase 1 with labeled video and text space for training. Input video frames that are cropped lip regions are sent into the model, and then the predictions are computed. And this computed predictions are compared with the uh, annotated data set what we have, what the real user speaker was trying to convey, whatever they were trying to speak, and is compared with whatever the output we get, and they both are compared. For example, the real text for video 1, this is output. So real text for video 1 was bin blue at 4 please. So the prediction which our model did was bin blue at 4 please. It was totally accurate. And for the second, it was bin blue at 5 again, and the prediction was bin blue at 5 again. As we see for the text for video 3 and same as video 4. If you see at video 4, there's bin blue at Z6 please, and a prediction which it did is bin blue at Z6 please. And as we come, if you see the real text for video 7, it is written as set white with SPV9 again, and the prediction which our model did set white with SPS9 again. So what we're trying to say that is the model is not 100% accurate. There's still some word error rate or character error rate. The thing is we have reduced the character error rate. It's very less as compared to previously. This is the output. So in the what are the conclusions? The first phase of project we focused on data collection, data pre-processing, feature extraction, and sequence modeling. Has successfully established a solid foundation for VSR using deep learning. So in the second phase, what we did was basically train the model, and we got the required output whatever was needed. So that was like analyzing text, and the data set was worked on more than 400 epochs, and we got the required output like whatever these were predictions. So future enhancement is we'll be working on thinking to work on real time deployment. So what is that? Is in real time we are able to analyze what the speaker is speaking, and we'll be able to convert whatever the user is trying to convey or speaker is trying to convey. This is a real time development, and in Another thing is we can work on the proxy interview thing where we have all know uh, there are proxy interviewers in virtual interview, the proxy interviewers who give on behalf of the candidates. So by analyzing the lip movements of the fake candidates who are having hired a proxy interviewer, so we can work on that as well. Future in we'll be working on that. So language and accent adaptability enhance the system's capability to support multiple languages, dialects and accents through continuous learning and transfer learning techniques. So currently we have worked only on English, but more and more data set is required to get more and more accurate result basically. So if we work more and more accents, the better the model will work on more real-time data. That's it. Oh, thank you.